Hello. Almost every company today is talking about carbon footprint, net zero targets, and greenhouse gas emissions. But an important question arises: how do organizations actually calculate their greenhouse gas emission? How can we estimate how much carbon dioxide is produced from burning diesel, generating electricity, or manufacturing products? The answer lies in standardized greenhouse gas emission calculation methods. In this video, we will understand how greenhouse gas emissions are calculated, the main calculation methods used globally, what emission factors are, and the most reliable sources for obtaining emission data. By the end of this video, you will clearly understand how carbon emissions are estimated in environmental assessments and sustainability reporting. So stay till the last. Most greenhouse gas emission calculations follow a simple principle. The amount of emission produced is calculated by multiplying activity data with an emission factor. The basic equation used worldwide is GHG emission equal to activity data multiplied by emission factor. Let us understand what these terms mean. Activity data refers to the amount of fuel consumed, electricity used, or material processed. For example, activity data may include liters of diesel burned, kilowatt hours of electricity consumed, tons of coal used in a boiler, quantity of waste disposed in landfills. An emission factor represents the amount of greenhouse gas emitted per unit of activity. For example, burning 1 liter of diesel produces approximately 2.68 kilograms of carbon dioxide. So, if a vehicle consumes 100 liters of diesel, the carbon dioxide emission can be calculated easily, right? Now, while carbon dioxide is the most common greenhouse gas, emission calculations usually include several gases. The most important greenhouse gases considered in climate reporting include carbon dioxide, methane, nitrous oxide, hydrofluorocarbons, perfluorocarbons, sulfur hexafluoride. Because each gas has a different warming potential, emissions are usually converted into a common unit known as CO2 equivalent. The conversion uses a factor called as global warming potential, commonly known as GWP. For example, methane has a global warming potential of about 28 times higher than carbon dioxide over 100 years. This means methane emissions are converted into equivalent carbon dioxide values when calculating total greenhouse gas emissions. The major GHG emission calculation methods. Different methods are used depending on the type of activity and the availability of data. The most common methods include emission factor method. This is the most widely used method. As discussed earlier, emissions are calculated using activity data multiplied by emission factor. For example, if a power plant consumes 1000 kilograms of coal and the emission factor for coal combustion is known, the CO2 emission can be calculated. This method is widely used because it is simple and reliable when emission factors are available. Second method, direct measurement method. In some cases, emissions are measured directly using monitoring instruments. This method is commonly used in large industrial facilities. Examples include continuous emission monitoring system, stack gas analyzer, industrial emission monitoring equipment. These instruments directly measure gases such as carbon dioxide, methane, and nitrogen oxide from industrial stacks. Although this method is highly accurate, it requires specialized equipment and is more expensive. Third method, mass balance method. This method is often used in chemical industries. It calculates emissions by analyzing the mass of carbon entering and leaving a system. For example, if a refinery or chemical plant the carbon content in raw materials and products is tracked. Any difference in carbon mass may represent emissions released into the atmosphere. Fourth, engineering calculation method. Sometimes emissions are estimated using engineering models based on process parameters. For example, combustion efficiency, chemical reaction stoichiometry, process operating conditions. These models help estimate emissions when direct measurements are not available. Steps in greenhouse gas emission calculation. Organizations usually follow a systematic process for calculating greenhouse gas emissions. Step 1, identify main emission sources. These may include fuel combustion, electricity use, industrial processes, transportation, or waste treatment. Step 2, collect activity data. This may include fuel consumption records, electricity bills, or production data. Step 3, select appropriate emission factors. Emission factors should be obtained from credible scientific sources. Calculate emission using formula. Activity data multiplied by the emission factor. Step 5, convert all emissions into carbon dioxide equivalent values using global warming potential factor. Step 6, report emissions under categories such as Scope 1, Scope 2, and Scope 3 emission. Now comes, where do we get the authentic sources for emission factors and data? The accurate emission factors are essential for reliable greenhouse gas calculations. Several internationally recognized organizations provide emission factor database. IPCC guidelines. The Intergovernmental Panel on Climate Change, or IPCC, provides detailed emission factor guidelines. The IPCC guidelines for national greenhouse gas inventories are widely used by the government and researchers worldwide. GHG protocol. The GHG protocol provides standardized methodologies for corporate greenhouse gas accounting. It also includes emission factor databases and sector specific calculation tools. International Energy Agency, or IEA, publishes energy statistics and emission factors for different fuels. These are often used in energy related emission calculation. National Environmental Energy Agencies. Many countries publish their own emission factors. Examples include United States Energy Protection Agency (US EPA), United States Environmental Protection Agency (US EPA), UK Department for Environment, Food and Rural Affairs, European Environment Agency. These sources provide emission factors tailored to regional fuel consumptions and technologies. Accurate greenhouse gas calculations are essential for several reasons. They help organizations understand their carbon footprint, identify major emission sources, develop emission reduction strategies, report emissions in sustainability reports, participate in carbon market and climate policies. Reliable emission calculations are also essential for meeting international climate commitments and corporate ESG goals. Conclusion. Greenhouse gas emission calculations play a crucial role in understanding and addressing climate change. By combining activity data with scientifically validated emission factors, organizations can estimate their carbon footprint and track their progress towards emission reduction targets. As global climate policies continue to evolve, accurate, transparent emission calculations will remain cornerstone for environmental sustainability. Understanding these methods is therefore essential for anyone working in environmental engineering and sustainability or climate policy. Thank you.